Our solar system began as a swirling cloud of gas and dust, a cosmic nebula collapsing under gravity. As it spun faster, the dense center ignited into our sun, while the rest flattened into a protoplanetary disk. From this disk, planets, asteroids, and comets formed, all sharing the same original spin. Viewed from above, the solar system is an orderly dance. Nearly every planet orbits the sun counterclockwise. Most moons follow suit, orbiting their planets in what's called a prograde orbit. This shared motion is a family trait, a signature of common origin. Even the moons of Jupiter and Saturn and their rings follow this rule. Why? Because they formed from smaller spinning disks around their parent planets. This harmony is the baseline of our solar system, the rhythm of the cosmic dance. But sometimes, something breaks that rhythm. When a celestial body moves against the flow, it hints at a different, more chaotic past. These outliers are cosmic rebels, and they often hold the most exciting secrets. In science, it's the exceptions that challenge our understanding. They force us to look deeper, to question what we thought we knew. Outliers are clues, breadcrumbs leading us to a richer picture of the universe. And one of the most intriguing outliers orbits far from the sun, around Neptune. Meet Triton, Neptune's largest moon, a true cosmic rebel. While Neptune orbits the sun counterclockwise, Triton orbits Neptune in the opposite direction, a retrograde orbit. This isn't a minor quirk, it's a glaring anomaly. Imagine a car driving the wrong way down a one-way street. Triton is that car. No large moon that formed with its planet behaves this way. If Triton had formed around Neptune, it would orbit prograde like other major moons. Its backward orbit is a blaring signal Triton is not native to Neptune. It's an immigrant captured from elsewhere. This single fact transforms Triton into a visitor with a mysterious past. Its orbit is a puzzle, and solving it means piecing together clues from its surface composition and behavior. Triton's retrograde motion is our first and most important clue. It tells us we're dealing with a cosmic kidnapping. To understand Triton, we must become detectives following the evidence of a dramatic capture. The story of Triton is one of the most intriguing mysteries in our solar system. Triton's retrograde orbit is the clue that something dramatic happened. It wasn't born a moon of Neptune, it was captured. This shifts our investigation from geology to cosmic forensics. The prime suspect for Triton's origin? The Kuiper Belt, a distant icy realm beyond Neptune, home to Pluto and other dwarf planets. If Triton came from there, it was once a dwarf planet itself, orbiting the sun. But how does a free-roaming world become a captive moon? A simple flyby wouldn't do it. Triton needed to lose energy to be captured. Theories suggest a violent process. Perhaps Triton was part of a binary pair. As the pair passed Neptune, one was ejected, stealing energy and allowing Triton to be trapped. Another idea. Triton collided with one of Neptune's original moons, losing momentum and falling into orbit. Either way, the capture was chaotic and violent. Triton's presence is the aftermath of a cosmic crime scene. The evidence is written in its orbit and its scars. The leading theory for Triton's capture is the binary disruption scenario. Picture Triton and a companion dwarf planet orbiting each other in the Kuiper Belt. Their journey brought them close to Neptune's immense gravity. As they approached, Neptune's tidal forces tore the pair apart. The companion was flung away, stealing energy, and leaving Triton slowed just enough to be captured. Suddenly, Triton was trapped in a new unstable orbit around Neptune. The once-free dwarf planet became a prisoner, forced into a backward path. This violent event left Triton in a highly elongated, unstable orbit. The capture set the stage for immense turmoil, reshaping Triton from the inside out. The evidence of this cosmic crime is etched into Triton's surface and core. The king of its own domain was now a rebellious satellite. This was not a gentle transition. It was a planetary-scale abduction. The aftermath would transform Triton forever. The next chapter, a world forged by fire and ice. Triton's capture was just the beginning. Its new orbit was highly eccentric and unstable. Each close pass to Neptune raised powerful tides, flexing and heating Triton's interior, a process called tidal heating. The energy was so intense it melted Triton from the inside out, erasing its ancient surface. The moon was resurfaced, reborn by Neptune's gravity. Over millions of years, Triton's orbit became more circular, the heating subsided, and its interior cooled. The legacy of this violent past remains, a young, smooth surface, few craters and signs of recent geological activity. Triton's original features were wiped away. What we see today is a world transformed by tidal forces. This trial by fire and ice set the stage for Voyager's most surprising discoveries. Triton became a geologically complex world, not just a captured relic. For centuries, Triton was a distant point of light. That changed in 1989, when Voyager 2 flew past Neptune and Triton. What it found was astonishing. Triton wasn't a dead, cratered ice ball, but a world alive with activity. Its surface was smooth and young, with few impact craters, evidence of recent resurfacing. Voyager revealed vast plains of frozen nitrogen, strange cantaloupe terrain, and long cracks and ridges. The biggest surprise, dark plumes rising from the South Pole, active geysers erupting into space. This was cryovolcanism, eruptions of nitrogen gas and dark dust, not molten rock. Sunlight heated subsurface nitrogen ice, causing it to erupt through vents. For the first time, we saw an active, dynamic surface in the far reaches of the solar system. Triton wasn't a frozen relic, it was alive, sending a message across the void. The geysers, smooth plains, and strange terrain all pointed to ongoing geological processes. Voyager's brief visit transformed our understanding of this distant moon. Triton became one of the most intriguing worlds in the solar system. Its surface told a story of recent change and hidden energy. The mystery deepened. What powers this distant world? Voyager's discoveries hinted at a deeper secret, a hidden ocean beneath Triton's icy shell. The young surface, active geysers, and lack of craters all point to internal heat and ongoing resurfacing. Triton's violent capture generated immense tidal heat, melting its interior. Some of that heat remains, aided by radioactive decay in its rocky core. This could keep a layer of water liquid, buried beneath a thick crust of ice. The ocean would be mixed with ammonia and other antifreeze compounds, staying liquid at extreme cold. This hidden ocean explains the geysers, smooth plains, and shifting crust. It's the missing piece that unites all of Triton's mysteries. To find life beyond Earth, we look for three things: liquid water, energy, and organic molecules. Triton might have all three. First, liquid water evidence suggests a vast subsurface ocean, possibly larger than Earth's. Second, energy. While sunlight is weak, tidal heating and radioactive decay could power hydrothermal vents, just like those that support life in Earth's deep oceans. Life can thrive in darkness, using chemical energy, a process called chemosynthesis. Third, organic molecules. Triton, like other icy bodies, is rich in complex carbon compounds. The dark material in its geysers is likely organic, irradiated by sunlight. This means Triton's ocean could be a rich soup of water, minerals, and organics. All three ingredients for life are present. Triton challenges our ideas about where life could exist. Even in the coldest, darkest reaches, the right chemistry and energy can create a habitable environment. Triton is a prime candidate in the search for life beyond Earth. Its story is just beginning. Voyager 2 gave us a glimpse of Triton but left us with more questions than answers. Is there really an ocean? What's in the plumes? Could life exist there? To find out, scientists have proposed a dedicated mission: Triton. Triton would fly by Triton with modern instruments, mapping the surface in detail and searching for changes since Voyager. A key goal: confirm the hidden ocean by detecting its magnetic signature as Triton moves through Neptune's field. Triton would also sample plume material, analyzing it for organic compounds. Though not yet selected, the dream of returning to Triton is alive. Triton challenges our understanding of habitability in the solar system. Exploring it could reveal new possibilities for life across the galaxy. The next chapter in this cosmic detective story is waiting to be written.